Okay, so we are going to talk about linear programming. What we want to do is an optimization method with linear equations. In the general form, it looks like this. We have to find a vector which we call x, want to maximize or minimize some equation, and we have conditions. And in matrix form, we can show it like this. And all the x values in the vectors, all the instances are non-negative. You can see more standard formula for this here. For example, we want to maximize the equation subject to some subject, and all the x are non-negative. Maybe there will be even an example. No. So what will happen is that we'll create a visibility region where we can find the solution. And in this region, we need to find the optimization point. We will have a vector, which is the C that you saw there, which is the vector, the direction in which we want to find the optimized value. And a perpendicular line in this direction of vector will tell us where to go to find the optimum. Will we go in this direction and find the optimum here, or will we go in this direction and find the optimum here, or go in this direction and find the optimum here? So this is the general form, and you can see here a more concrete one. We have the condition, and the condition builds those lines, and intersecting those lines we can create the visibility region, because under this value all this will be visible, under this value all this will be visible, under this value all this will be visible, and when we intersect these regions we get the visibility region. Now our S that is here, which we called C there, will give us the direction as a vector. This is S1 and S2. So S1 is 4 and S2 is 3, for example. So the vector is in this direction. It will tell us to go in this direction to look for the solution. So what we will do, we will take a perpendicular line and go in the direction that the vector S tells us until we hit a maximum optimization point in this visibility region. This optimization point will be our solution. Another way to get the solution is just to plug the intersection between the regions and to see which one, if we plug it in our formula, give us what we want. If we want to maximize, so which intersection point give us the highest value for the formula. This will be our solution. Note that sometimes there will be no solution. For example, if the visibility region is all of this and more for infinity minus infinity, so if the vector of S would have been in the direction opposite to the direction we see here, we would have had unbounded solution. So here you can see a bounded solution with a solution that we got to, but there are other options, but this is just a very simple example to show us how we can solve linear programming in 2 dimensions using geometric approach. Now there are other algorithms like the simplex algorithm, which we are not looking at here. We are just looking to solve linear programming in a geometrical approach, and this is how we do that. Take the conditions, plug them in as lines, find the intersection between the regions in this region that the condition tells you. Find the intersection, this is the visibility region. Take the vector from the formula that tell you which direction to look for the maximum or the minimum, the optimization point, and make a perpendicular line. Find the optimization point that is the most optimized in this direction. Other way is to take the intersections and plug in and see which intersection point give you the maximum or the minimum, depends on what you are looking for. And this is about linear programming in geometrical approach. This is it. If there are any correction or mistakes, please tell me, and that's it.